All right, so we have found that so far the derivative of sine is cosine, derivative of cosine is negative sine. It seems like this family wants to stay within itself, right? They don't want to go outside, like sine and cosine are both in the family of trig functions. And maybe, after differentiating, being differentiated, they still want to stay within the family. Maybe that's what's happening. Okay, so let's look at the tangent function and see what we can do. Is there anything we can do to analyze this? Well, we do know the tangent is sine over cosine, right? We know how to differentiate each, and we have the quotient rule. Wow, we have everything we need to derive this derivative, okay, for the tangent function. Sounds redundant to say derive this derivative, but to differentiate the tangent function. All right, the denominator is simply the square of the original denominator. According to the quotient rule, the numerator will be the derivative of sine times the denominator minus the top itself times the derivative of the denominator, which is negative cosine. Okay, so well, that's nice. See, we didn't have to take the limit of as h approaches 0 anymore. This is cosine square plus sine square. Wait, have you seen that before? Of course you have. Okay, this is what I call the mother of all identities, right? And remember I said, this is not going to change forever, okay? So if 100 years from now, if you happen to be still alive, and if somebody asks you, hey, great-great-granddad, what is the answer to cosine square plus sine square? You can confidently say 1, and it's been 1 ever since the foundation of the world. And then you have cosine square in the denominator. So what is that? It's secant square, okay? So the derivative of the tangent function happened to be secant square. Cool. Still trying to stay within the family of trig functions. How about cotangent? Okay, so this will be the opposite, right? It's cosine x over sine of x. All right, so what is, according to the quotient rule, what is this? Well, the denominator is sine square x. The numerator is the derivative of the first, the top, which is negative sine square, times the bottom, minus the top times the derivative of the bottom. And because the denominator used to be sine x, it's going to give you cosine of x. All right, so is this something familiar? Well, let's factor out, the negative sign. Then you have sine square x. And remember, this changes into a positive because I have factored out the negative sign here, right here, and then cosine square x. And you say, wait a minute, I have seen this before. Yes, you have. The top is negative times 1, and the bottom is sine square x. This is known as negative what? Cosecant square x, which is the derivative of the cotangent function. You see how they're related to each other, and one is positive and the other is negative? Very similar to what you saw in sine and cosine functions. Oh, this is fun, man. We are running fast. Look, we are finding all kinds of derivatives. We can't wait to go to exponential and log functions now, right? And a bunch of other functions. Okay, all right. So what's the next one? How about secant? All right, what is the secant function? That's 1 over cosine function. Do we know how to take the derivative of this? Of course, we use the quotient rule. What else, right? The denominator is the old denominator squared. The numerator, what's the numerator? It's the derivative of 1, which is 0, times the old denominator, minus 1 times the derivative of cosine, which is negative sine. Okay, so this happens to be sine of x. Oh, that's different. Over a cosine square of x. Okay, so you can write it that way, but You can also write this as 1 cosine x times sine x over cosine of x. You see that these are equivalent. I just wrote cosine square, as cosine square, cosine x times cosine x. The top is 1 times sine of x. The reason I write it this way is because now we can see this is the product of two trig functions. It is secant, tangent. All right, so again, the derivative of the secant function is secant tangent. You just have to just add tangent x after the original secant x, and that is the derivative. Smooth ride so far. The last one of the 6 trig functions, we have had sine, cosine, tangent, cotangent, secant. Now the last one is cosecant. The other ones were nice and easy, so this should not be a problem. And indeed, it's not. When you take the derivative of 1 over sine squared, the denominator becomes sine squared x. And then the top is the derivative of 1 times the sine of x minus 1 times the derivative of sine of x, which is positive cosine of x. But remember, you have a negative sign here from that a quotient rule. So the answer is negative cosine over sine squared. What's that? It's negative 1 over sine squared times cosine x over sine of x. Writing this will allow us to see this as the product of two trig functions. It's negative cosecant, cotangent. All right, so the derivative of cosecant is negative cosecant, cotangent. Again, one of them turns out to be positive. The other one turns out to be negative. It seems like secant and tangent kind of go together. They're like brothers. And cosecant and cotangent go together. They are also like brothers. And you see that? I mean, because like for tangent, you have secant square. Cotangent will give you negative cosecant square. So you see how tangent and secant seem to be closer than, secant and cotangent. But cotangent and cosecant seem to go together. So keep these in mind. All right, now we have the derivative of each of the 6 basic trig functions. How awesome is that? Okay, let's do an example. And then we'll do one more thing after this example, and we will finish section 3.5. Here, let's differentiate. And you'll see a lot more questions, homework, problems, or assignment to do. And it is important for you to continue doing that because that's how you learn, okay? As people say, mathematics is not a spectator sport. You don't get better just by watching somebody play. You can watch a famous basketball player play basketball all day long, all year long, and that's not going to make you a great basketball player. So you can watch this video day after day, and that's not going to make you a great mathematician. All right, so x squared times cotangent of x. All right, let's take the derivative of this. Oh, you know what? Let's not do this. Okay, I'm going to just do x times cotangent of x. And the reason is because I don't want to make this too complicated. I'm going to do this in one other way after this, right? So what is x times cotangent of x? Well, that's the product of 2 functions. One is polynomial, the other is trigonometric. The derivative, according to the product rule, is the derivative of the first times the second plus the first times the derivative of the second. The cotangent gives you what? Negative cosecant, right? Cotangent function, if you look up here, negative cosecant square. This is what you get. And so this is what? Cotangent of x minus x cosecant square x. So that's the answer to that question. No problem, right? Okay, I'm going to give you another question. So this number, this is A, this is B. This time it's x over the tangent of x. Right now, you may have noticed this is the same function as this. Do you see that? If you have 1 over tangent, it's the same thing as cotangent. So these are exactly the same function. So the derivative had better be the same, or at least they should be equivalent. Okay, let's verify that. The derivative of this quotient, according to the quotient rule, is going to have the denominator, which is the original denominator squared, and then the top is the derivative of the top times the bottom minus the top times the derivative of the bottom. The derivative of the tangent function is secant square. All right, so the answer to this question is tangent. Well, actually, let's go ahead and split this into 2 parts. The first part is tangent over tangent square. So that's 1 over tangent, right? The second part is x times secant x squared over tangent squared. Okay, so the first one, I think you can realize this is just cotangent, right? Yeah, it is. Okay, and then minus this thing here. The second term is, let's try to figure this out. Secant, of course, is 1 over cosine. So you can write the top this way. The bottom is sine square over cosine square. That's tangent square, right? And you can easily see these 2 things could be canceled. And so the answer here is cotangent of x minus x times 1 over sine square. We have a name for that. We have another name for that. That's cosecant square, right? And of course, these are the same function, the same derivative. And again, that's not surprising. In fact, it is expected because we started with the same function. All right, so that is good. When you get the right answer twice, that's a good sign. All right, one more thing before we close. And again, this is also a wonderful topic, an elegant topic. Look at the higher order derivatives of these trig functions, mainly sine and cosine. Okay, so I'm going to go to the next page here. Just look at sine and the cosine functions. If you take the first derivative, what do you get? It's cosine. How about the second derivative of the sine function? Well, it's going to be the derivative of the first derivative, which is cosine. So it'll be negative sine of x. The third derivative is negative cosine of x. The fourth derivative, which we can write with this 4 inside of the parentheses, is sine of x. Remember, this is negative sine of x, which is positive sine of x. Okay, so that brings you back to the same thing. Okay, so every fourth one would be the same. All right, so for instance, the 100th derivative of the sine x is also going to be sine x. Remember, every fourth one is the same. It's almost like, you have, oops, what happened? It's like, you remember your the I cycle or icicle? When you square I, you get I square, which is -1. And then if you multiply the I cubed is -I, and then the last one is 1, okay? And then goes back to I. So this is a cycle of 4. Every time you do this 4 times, you get back to the original one. Same thing here, 1, 2, 3, 4, and back to the original. Cosine becomes negative sine when differentiated. The second derivative is negative cosine. The third derivative is sine. The fourth derivative is cosine. Again, back to its original after 4 differentiation steps, right? So both of these have this common characteristic. What is that? The derivatives, higher order derivatives, form a cycle of 4 different functions. Okay, so for each of these, the derivative or the second derivative, notice the second derivative is exactly the opposite of what you started with. Okay, in other words, the second derivative of y plus y is equal to 0. Okay, Now you can look far and wide. And by the way, this is actually a very important equation. This is called the second order differential equation. And you will study more about these things in course differential equations, of course. But it turns out this is a pretty important equation that governs many things that go back and forth and oscillating motions such as spring and waves and all sorts of things that are important to physicists and other scientists. And it turns out, okay, the only functions that would satisfy this differential equation happens to be sine of x, cosine of x, their multiples by constant, and any combination, linear combination of these. Okay, so that's something to remember. Okay, and it gives you a sort of an insight as to how important sine and cosine functions are in the world in which we live. All right, so if I ask you the 10th derivative of, here's a sine function. If I ask you to differentiate it 10 times, can you tell what that is? Well, the 8th derivative. Oh, by the way, you can also write this in this strange way, if you remember. Sine of 10, and then dx to the 10th. The 10th derivative of sine is, well, the 8th derivative is the original sine, and then the 10th derivative is going to be the negative sine of x. Okay. If I ask you to find the 97th derivative of the sine function, well, the 96th one is sine, so this will be the cosine of x. Okay, all right, great. So now we know how to differentiate the 6 trig functions. We are making great progress, all right? Next time, we will study section 3.6, which is going to help us differentiate compositions of 2 functions. Until then, I hope you will have a great time continuing to enjoy calculus. All right, take care.